There we go. All right, thanks for having me, everyone. I'm Michael Rainey with Snowflake Computing, and I'm the guest speaker here. So this is my first time speaking at Oaktable World, so I'm pretty honored to be able to do that. This is Going Serverless, an introduction to AWS Glue. Okay, so first off, what is serverless? So who has a definition? No, who's heard of serverless? I think probably most people, yeah. And any good definitions out there? What do you think serverless is? Anybody want to take a shot? Oh, everybody wants to take a shot. Okay. Vit, what do you have? Program as a service. Okay. You don't have to worry about what it's running, where it's running. Okay. Anything else? Did you have same thing? Okay. Yeah, pretty much. I'm going to tell you anyway. Well, originally it's started out as function as a service. So AWS Lambda was the original serverless, application, and it was doing just that, running functions in the cloud without knowing what's going on behind the scenes. You just run your program. It could also be considered fully managed. So that's kind of the other definition you guys threw at me. I don't care what's behind the scenes. I don't know what's going on as far as the server, what the CPU and memory looks like. I just run my program, and all the scalability, high availability is done for me. I don't worry about it. But also, what I think is serverless is just allowing developers to focus on more value-driven activities. So what do developers want to do rather than manage servers or worry about memory and CPU usage? They just want to do development, right? So serverless allows developers to focus on that. And we're going to talk, it's not just serverless functions, but we're going to talk about serverless ETL with Glue. And there's an interesting quote that I found from Nick Rockwell. He's the New York Times CTO. And he wrote a blog post, I think it was about a year ago. Any platform, so this is his definition of serverless, any platform that provides utility while completely abstracting, scaling, and reliability. So again, you guys hit on it. Scalability behind the scenes. You don't have to figure out if you need extra nodes and do something manually to provision those extra nodes to process your code. It will happen for you. Reliability, you don't have to set up any sort of high availability. It's just done behind the scenes. You have a distributed system of some sort that AWS or Google or whoever is running for you, and you just throw your program at it and it handles it. And the interesting thing, this CTO for New York Times, he said he wants to go entirely serverless at the New York Times by, I think he said, next year. So this, like I said, it was written about a year ago, so I haven't checked in to see where they're at with that process, but that's pretty cool to hear that. Okay, and so where serverless fits in kind of the cloud space, off to your left, we have the infrastructure as a service. That's like your bare bones machines. That's, an AWS EC2 instance or, bare metal and Oracle Cloud, something like that. I mean, you basically have a server, the storage, the network, some sort of virtual environment probably, and then you provide everything else. So server in the cloud, basically. Platform as a service, the next one, that's getting closer to like maybe Oracle Big Data Cloud Service. So that's something where you have not just the hardware and virtual environment, but you also have the operating system, the middleware, the runtime environments all set up for you. You provide the rest of it, the application and the data behind it. And serverless is right there in between platform as a service, and then off to the right is software as a service. So that's like your Gmail, Salesforce, Dropbox. That's just, it's software in the cloud. You can configure, you can write connectors, you can do things like that, but you can't change how Gmail delivers mail. You don't have control over the application. So it's all done for you. But serverless fits right there in the middle. And again, it could be FaaS for function as a service, but it actually does, serverless kind of encompasses several other things as well. So it's not just that. All right, so in the beginning, as I mentioned, AWS Lambda was the first serverless application or platform out there back in 2014. And then some others came along. So Google Cloud Functions, Microsoft Azure Functions, those are both just similar to Lambda. The FN project is something new out of Oracle that's kind of, it's been sort of developed on the side, it's open source, and they're doing a ton of sessions this week, I noticed. So the FN project is more of a serverless platform on top of these other applications. So they're trying to make it a little easier to use, I guess, a multi-cloud serverless environment. But then there's these other things like Amazon Athena. It's a query engine in Amazon. And you just have metadata and your query window, and you can run queries against data that might be stored in S3 or elsewhere. But you don't worry about what's going on behind the scenes. You don't know that it's Presto running on whoever knows how many nodes. It's just running a query for you. Google BigQuery, similar thing. And then even Snowflake is somewhat serverless in that, and I'll kind of get to some of the definition, but you pay as you go. You pay for what you use, that sort of thing. And so that's kind of part of why serverless. Pay as you go. You don't pay to have a server sitting there idle waiting for an application or a job to be thrown at it to run. You only pay for when it's actually operating. We already talked about the fully managed, the scalability, and even the ability to develop and ship code faster. You have the ability to try things out more quickly. And some use cases, interestingly enough, a lot of the Lambda use cases, when I was doing some research on this, when Lambda first came out, a lot of the use cases were just data pipelines. People were just trying to move data from one place to another. And that's now we have Glue and some other serverless ETL to do that. An interesting one I saw was websites. So you could actually store static web pages for your website in an object store like S3 or Google Cloud Storage, and then use the serverless function to interact with people on the website. So maybe you have something where, like a site where you're having images uploaded. So when an image gets uploaded, your Lambda function picks that up. Maybe it does some processing to make sure it's a valid image, it's suitable for the internet, etc. And then stores it away in your Google Cloud Storage. And then you're done. You pay for that little interaction, and that's it. And actually, I just thought about this because I've been seeing tweets about it, but if Troy Hunt, he's the security expert that is, what is his site? I forget what it's called. Have I Been Pawned? Is that it? But he's got this huge following, and this is how he runs his website. And actually, he's been tweeting lately about how he broke Azure Functions because there were too many hits on his website. So, yeah.
You said something intriguing. Suitable for images, suitable for the.
Yeah.
What is that?
Oh well. Suitable for, yeah. I guess it depends on what your website is. Yeah, it's all right. I saw you perked up there. But yeah, so there's all kinds of use cases available there. Some challenges, limitations where it gets a little hazy here. So monitoring, and all of this is starting to get better because serverless is still growing. Monitoring and debugging could be a little bit rigid, I think. Whereas maybe you're used to writing applications and you have control over the debug capabilities, control over the way you monitor it. Now you're sort of tied to the cloud provider's capabilities. So for AWS, you have like CloudWatch and so on and so forth. Integration testing. So think about, you have maybe an application that's made up of 15 different Lambda functions. So now how do I want to change one? Where do I test it? you know, I don't put it in production to test it, but you know, I have to figure out how to do that full integration testing along the whole way. The startup latency is actually still a thing. That's, you know, where if you start up your function, there might not be a provisioned server waiting for you, and so you might have a little bit of delay while AWS or whoever the cloud provider is brings that up. It's built for small and short processes. This is function as a service again. Glue, as we'll see here in a second, you don't have the limitation of time. You're doing data processing, data transformations. It's going to take more time than 5 minutes. But for these function as a service, they try to limit you, little tiny chunks. And then the multi-cloud, again, it's getting more difficult to access data, or more easy to get across, access data across multi-cloud. Yeah. Yeah, I did. Yeah, I thought about mentioning it, but yeah, they did bump it to 15 minutes now for Lambda. So, but yeah, it's still quite a short time depending on what you're doing. And then yeah, the multi-cloud is getting better, but it's still, you have some challenges there trying to move data across, you know, the different cloud providers. All right, so that's the intro to serverless. Let's talk about serverless ETL while we're here, AWS Glue. So AWS Glue is a fully managed serverless ETL service, extract, transform, and load. And so all of these headers that I'll show here, in quotes, those are direct from their documentation. So, you know, just to let you know, there's 4 different major components to Glue. The first is a data catalog, and that's basically the metadata that you're storing. So and we'll get into the details of each of these. The crawlers, this is where it's actually getting really powerful. The crawlers in the data catalog. The crawlers can go out into a table structure or into your S3 buckets and directories and figure out the schema behind the data that's stored there, and then create the metadata in your data catalog. And so and you have lots of options on how to do that. Then of course it's an ETL tool. You have ETL jobs and scripts. And then what's an ETL tool without a job scheduler built in? So we have that as well, a way to run the jobs. And why would you use it? Well, you know, of course it's for ETL pipelines. Running serverless queries against, you know, multiple different sources, combining those different sources, you know, as you would any ETL tool, combining S3 data with relational data, something like that. Or maybe you just want to, you know, automatically discover and catalog all of your different, you know, data assets that you can connect to with Glue. So this is a look at the architecture, and this is from the documentation, but I cleared out some of the clutter and highlighted just the Glue pieces here. So off to the left, we have, these are the sources, which we'll get into a little bit more later, but this is kind of where you can pull data from and connect to. In the middle, we have Glue, and you can see centralized is the Glue data catalog. So that's really the center of Glue, even though it's an ETL tool, that data catalog is very important. Then you have your crawlers, which add metadata to the data catalog. You have the Hive DDL statements, you know, the actual create statements, and then the Glue ETL. But also, besides the Glue ETL off to the right, using the data in the data catalog, you have these other services that can use that metadata as well. So Amazon Athena, that query engine, can use it. EMR, which is their Hadoop in the cloud in Amazon. Redshift, which is their data warehouse in the cloud. They can all use that centralized metadata that's being used by your ETL tool. And I think that's probably where, you know, Glue can, if they continue to add more services to it in Amazon, you know, that's really powerful to have one single metadata source that you can use all of your applications against, run all of your applications against. Okay, so the data catalog, central repository to store your structural and operational metadata for all of your data assets. It's a little bit of a marketing, all of your data assets if they're accessible by Glue. So it's the metadata catalog is actually it's built on Hive Metastore, so it's compatible with the Apache Hive Metastore. So that's why it can be used by things like EMR as a metadata resource. Just like you think any other ETL tool, the structure of your metadata looks a lot like a database. So you have databases. Within those databases, you have tables. Each table has columns, data types, etc. And here you can kind of see, this is my kind of garbage test data. So there's some of these tables don't make sense, but the table name, the database where they live in, and then your location. So these are all files within S3 buckets. And then the classification, and that's the type of file that you're accessing. So Parquet, ORC, JSON, CSV, it could just be a table in a relational database. And you can create this metadata, again, using the crawler, or you can manually add it using a wizard. The data sources you can connect to with Glue. This is all of your data assets. So S3, like I mentioned, and then there's a bunch of different relational databases, Oracle, Postgres, there's the Redshift, Aurora, MySQL, SQL Server, and then there's even the custom JDBC connector. So you could probably get to most of your data assets with this, but the crawler won't always be able to crawl everything that you connect to with the custom, JDBC connector. So, but you'll have the ability to get a lot of that information in. Yeah.
So in terms of setting this up, is it crawl everything in your account, or do you actually have to tell it what to crawl?
Let's talk about crawlers.
Okay,
good segue. Yeah, sorry, did you have another?
Yeah, and then it goes down to the actual table structures.
Yeah, so yeah, I'll tell you right here. But yeah, that's perfect. You can set it up, and configure it. So crawlers, again, they connect to one or more data stores, figure out the data structure, and then write that into your data catalog. And so yeah, configuring the crawlers, you can include or exclude specific objects, file paths. There's a lot of configuration you can do with it. It can detect the partitions. So if you have partitions broken out into folder structure in S3, it can figure that out. It also detects schema changes. So an example might be, say you have in North America 4 sales regions, or in the US. So each of these regions has a CSV file that they load their sales data into 4 different buckets. You can configure your crawler to look at those 4 different buckets and think of them as a single table. So you have one single sales table, or you could have 4 individual tables in your metadata. Depends on how you configure the crawler. Now, if maybe the Southeast, those guys down in Atlanta, they decide to just go rogue and add a few more columns to their file. So that's now this is how you do it, right, Danny? Yeah. So the other regions, they've got the same data structure. Now we have something different coming out of the Southeast. So it comes in and you run your crawler again, it's going to figure out, oh, look, there's new columns, and you can configure what to do with those. Ignore them, bring them in. If you bring them in, hopefully your ETL job can handle that. Otherwise you're going to have issues. But you can figure out, you can handle those as they happen. And you can schedule crawlers. So in case you are expecting changes or new data types, you can schedule it to run on a regular basis. Okay, and there's something called classifiers, which could probably be a talk on its own. So this is where within the crawler, you have the ability to, if you know specifics about your data types, you can you can tell it how to cast certain data types into the metadata within your data catalog. So that there's built-in classifiers, so you don't have to write these if you have pretty straightforward data. But if you have certain unique cases, then you might write these out and build your own custom. So this is the example there is just casting a number to an int using Grok is what it's called. So the way when you process these, or when you run your crawler, it'll process a list. You can provide it a list of classifiers to run through. And it's basically, you know, if I don't find 100% match on this classifier, just try the next one and the next one until it gets down to the generic ones and it tries its best. So it's, again, you know, pretty powerful the way you can configure it there. Okay. Jobs. It's the ETL job. It performs the business logic for your, it's the business logic that performs your ETL within Glue. So the jobs are PySpark or Scala, generated by Glue. So either generated by Glue or you can provide your own script. So Glue is actually just a layer on top of the Spark SQL. So you have this Glue API on top of that. There's, again, like any other ETL tool, you have built-in transformations. So there's a bunch of different templated transformations you can drag and drop onto your script and fill out the template. So, you know, think of like Oracle Data Integrator has components for joins, filters, you know, all of that. It's the same concept. Now, the data structure that Glue uses on top of it's something called a dynamic frame, which sits on top of an Apache Spark SQL data frame. So the difference there is the data frame in Spark SQL requires a schema before you can load data into it. So think, you know, schema on write, and the dynamic frame actually doesn't. So it's more like schema on read. So you can load some data into your dynamic frame and it'll figure out what it thinks it is. And then maybe you load data again and something's different. So it's going to try to figure it out. And you'd have to write this into your code, but you can then ask, tell the data frame how to handle any discrepancies. So it's kind of interesting how they allow you to do that. But that's, I think, to handle those changing, the changing metadata, the changing file types. You can actually create a visual data flow with Glue. So you can't actually develop with it or anything like that. It's just simply for visualization. But when you have a bunch of script, it's kind of nice to be able to have that visual and look and see how the data flows through. The interesting thing is it's all built based off of your comments in your code. So it doesn't actually read the code to figure out the data flow. You have to comment it out, and so you can really hack this thing if you want it to look a certain way. So just beware. Yeah. What's that? Yeah, weird, huh? There's no comments. So there's pretty much no visual data flow. But yeah, so you actually have to fill out the comment with what the step does, and we'll kind of look at that a little bit later. You can use the visual interface in the cloud and in the website on Amazon, but you can also either write Glue scripts in your own IDE, your own development environment, or through a notebook. So if you want to do it different ways, you can do that. Here's a look at some of the kind of standard transforms that are available. This is just a small list, but you see the usual suspects, mapping source to target columns, filters, joins, applying functions, selecting certain fields. So if you join some data frames or dynamic frames together, you want to select only a subset of those fields, you would run that, et cetera, et cetera. So there's a lot more out there you can have a look at. And it's a very simple syntax. So in this case, we're just joining persons to memberships on those two columns. And that's using the dynamic frames and the actual built-in transform there. Okay, so running a job in Glue. And with Glue, because it's serverless, you only pay for the time it takes your job to run, right? So you can fire off jobs several different ways, the scheduler, different events, or just manually run it, maybe through your notebook or IDE. And this is how they calculate not only the cost, but also the capacity that you are using, the processing power you have behind your your code, your job. These are the DPUs, data processing units. One single DPU is 4 virtual CPUs and 16 gig of RAM. So it's almost like a MacBook, right? So maybe not the 4 virtual CPUs. But so that's one DPU. You can set the default value for your job to whatever you want between 2 and 100. So the default is 10 when you first start up and create a job. So beware if you're just trying to write out, hello world in your ETL or something, don't use 10 DPUs. It's going to cost more than it needs to. Just set it to 2 and you'll be fine. So it's billed 44 cents per DPU hour in increments of 1 second with a 10-minute minimum duration. So what does that really mean? I don't want to do the math. They have a simple example out there on the Glue website. So if you have a job that runs 10 minutes and consumes 6 DPUs, your job runs for 1/6 of an hour, consumes 6 DPUs, so you're billed 6 DPUs times 1/6 of an hour at 44 cents per DPU hour, or 44 cents. So that's a really simple example to kind of understand, what it costs. And I was playing around with Glue, just putting together some examples last week, and I think I spent $4, and I was running things every evening, testing it out. Very small jobs, but it's minimal until you start getting some, probably when you get some big processes, then you'll see the cost go up. Okay, that's not clear at all. I'm going to talk through the wizard, so how you create a job in Glue. So, and unfortunately, you can't see it very well, but imagine, if you will. So first, when you create the job, you have the ability to give it a name, and then you have to choose an IAM role in AWS. And so you have to be careful with this one. There's certain Glue roles that you can, when you create your IAM role, you attach to that and make sure it has access to all the Glue services. You also have to make sure it has access to the temporary directory that you define in case it needs to dump data out to a temp directory within S3. Also where the scripts are going to be stored, and access to any other S3 data. So you got to make sure that you have all those ducks in a row, and can be a little tricky sometimes. The job, you can say, go ahead and create a script for me with this wizard, or I'll provide one, or just give me a blank slate and I'll start typing in my script. You can choose your code language, Python or Scala. Give it the script file name, where the script is going to be stored, and where the temp directory is. Then you get into advanced properties. And I can't even see this here. There's some in the middle there. There's spots for Python library paths, dependent jar files, and any other reference files that you might need to access for your Glue job. So if you have additional things functionality you want to add to your Python scripts, then you can do that. The concurrent DPUs per job run, that number 10, that's where we want to change that if we're just starting and trying it out. That's the default when you first run your job. But every time you execute your job, you can change that number. So if you think, I'm running my job at 10 DPUs and it's starting to slow down because I'm getting a lot of data, so maybe let's just try to bump it up to 15 next time I run, see if that makes a difference. And then maybe you change the default later on. Max concurrency, how many iterations of this single job can run at the same time. So maybe our 4 different regions, we want to just write one job to capture all those files and process them. And maybe we'll, within our job, we could parse the file name, figure out which one it is, and then have different logic to handle each region. I will at least need four jobs to run concurrently, right? Then there's a timeout, and the default there is, I think it's 2880 minutes. So you have a lot more time than a Lambda job. So because, we are processing data, it takes a long time sometimes. And then how many times you want to retry. So here's where the wizard is kind of, doesn't make a lot of sense. Right now, they allow you to choose one source table and one target table, and that's it. And then you map columns, and that's it. so it's not much of a graphical user interface to get started with your job. It does give you a start, though. So here I just have a source and a target, and I map columns that I want, and it gives me a nice little script. And so off to the left, that's our visual diagram based off of the automatic comments that it created for me. Off to the right, that's the script itself. And so you can see I've highlighted the database or the table name at the top. And what's nice is it highlights the code for me. So imagine if you inherit somebody else's script and you have this giant thing and you don't want to scroll through the whole script to figure out where it failed. Just find it in the data flow the visual data flow diagram, click it, and you can go right to that code. So that's a nice little feature there. And really this thing, because it was just a single source to source map or source to target mapping, there's not a whole lot to it, but it's applying mapping. So mapping the columns, selecting the appropriate fields out, and then outputting the data. One other nice thing about selecting that table name, you can actually see down below the schema. So I don't have to go out to my metadata catalog to figure out what the table and column names are, or the column and data types are. I can see it right there. All right, so here's a different visual diagram, and don't worry about the words on there. It's just a visual for you. But this is another example I put together. So 3 different data sources, all in S3. We've got customers, demographics, and sales. So first thing I'm going to do is select the fields I need from each of those different dynamic frames. Then I join them. So I can first join the sales or the customers and demographics. Then I'll join that dynamic frame into the sales as well. And then I do something else. And this is where I actually just sort of hacked the comment and said it was a join so I could get the visual diagram to work. But I've done some custom code behind the scenes on this one because the functionality wasn't there built into Glue. Oops. And then finally, I output the data at the bottom to a new file in S3. So here's where you can get in there and do anything in PySpark that you want to. Spark SQL, you can run any of that code that you want. So here I'm taking my customer demo the customer demo sales dynamic frame and converting it to a data frame. So I can do some Spark SQL functions on it. And this is, I just pass in a Spark SQL query to run against the data frame. And what I was doing was getting average with a partition by for various fields. So that's something that's just not built into the transforms within Glue. So I can do that, and then I convert that back to a dynamic frame so I can output it continuing to use Glue. So again, you can do all kinds of stuff out there. And there's actually a GitHub repository with some Glue examples from the Amazon team. And really none of them have the comments for your visual. They just wrote code. So it's just, and which is great because you get good examples, but yeah, it's not like the wizard. Okay, so how am I doing on time here? I'm good. So I changed this one up from the last couple times I presented because now I'm at Snowflake and there's a way to connect Glue to Snowflake and use it. So I kind of wanted to just talk through that and how you can use that custom connector for Glue to connect to some of these other sources. So before I get into it, Snowflake is a data warehouse in the cloud, and it has 3 different services, or 3 different layers. So at the bottom is the storage, and right now Snowflake runs in either Amazon or Microsoft cloud. So the storage is either S3 or Microsoft Blob Storage. In the middle, there's the virtual warehouses is what it's called. That's basically your compute. And you can spin up as many of these as you want to access the same data without copying or moving the data. And they don't contend with each other. So there's no, so you could have one for ETL, one for your reporting, et cetera, et cetera. And then on top of all of that is the security, the metadata, everything that makes Snowflake run is kind of our services layer up there. Okay, so to set up Glue with Snowflake, first you just need to drop, there's two different jar files. There's a Spark connector for Snowflake and a JDBC driver. So to give you the connectivity there. Just drop those into an S3 bucket, and then we'll put that path in the dependent jar files. So the path to each of those files in your dependent jar files spot for your job in the job properties, and then you're ready to go. Another piece of configuration for the job itself is the parameters. So these are parameters that you can pass into your job as you execute it. And so here we just pass in information about the Snowflake server we're connecting to, the database, the virtual warehouse we're going to use, the schema we're going to access, and username and password. So we have that set up here, and there's ways to store an encrypted password in S3 or in EC2 and handle it that way. But so if you don't want to have a hard-coded password out there, but that's just as simple as it gets to get those parameters in there. And so here, I'm not going to go through all of this code. I'm just going to highlight a few pieces. So at the top, you're importing all of your Glue and Spark classes. But here's an important thing for your Spark connector for Snowflake is this variable Snowflake source name. And we'll use that throughout when we connect to Snowflake through our Spark connector. Then we have some more setup of your Spark session, your job within Glue, you know, kind of just some manual, regular stuff. And then we have the ability to, we have this setup of push down for Spark into Snowflake. So what that means is when we run a job, if we have data in Snowflake as a source, you know, maybe multiple tables, we can actually push our joins, our filters down to Snowflake to do the processing, rather than pull all of that data into Spark and run it in our Spark cluster, or I guess in Glue, run it in the Spark cluster behind the scenes in Glue, and then push it back. We can just do it all in Snowflake with this push down capability. And it's not unique to Snowflake. There's other connectors to Spark that do the same thing, but you know, it's a very cool feature to have. And then finally, here's our parameters we set. And this we use to, again, along with that initial Snowflake source name, we'll pass these parameters into our Spark connector to make sure we can connect to the database in Snowflake. Okay, and then running the job in Glue. This one, I broke it down into a bunch of different steps so it's easier to look at. But this is basically grabbing the employee table, which is an S3. And then I take a monthly sales table, which is in Snowflake. So these are actually using data frames in Spark SQL. So I'm not actually using the dynamic frames at this point. Then I can do group by. So I'm going to group. I want to see all the sales by employee and month. I'll join that to my employee table so I can get the employee name out of it. And then finally, create a final data frame so I can output that to Snowflake, to a new Snowflake table. So pretty simple, just writing some Spark SQL code or some Spark PySpark code there to do my data processing. And again, you know, that whole thing is pushed down into Snowflake because that's where I had enabled that push down to do the processing. And then our result is employee, month, and their total sales. So hopefully that's good for them. But as you can see, it's pretty straightforward to set up your connector from Glue to Snowflake. All right, so why would we use Glue with Snowflake? Well, we're going to run, you know, have event-driven pipelines possibly, you know, so maybe we'll have a process that loads data into S3 and then just trigger something to copy that into Snowflake. And there's a command in Snowflake you could run to do that. Or maybe we have S3 as a source, we have data sitting there, and we have Snowflake as a target, but we could use Spark because the data is in S3. We use Spark to process that data in Glue, and then the final results get pushed to our data warehouse. Or maybe Snowflake's the source and target, right? So kind of like I talked about with the push down, let's process everything in Snowflake because everything's, all the data is there, and that's where we're going to store our final result anyway. And again, you know, you can combine all different kinds of sources within Glue. So it could be Snowflake, it could be Oracle, it could be S3, could be all of them combined in your transformations and then loaded somewhere else. And really, you can replace Snowflake with any other relational database I talked about, or any other source that Glue can connect to. This is just kind of an example because I was talking Snowflake just now. The one thing we can't do is understand all of our data assets with Snowflake. So right now, the crawlers don't work with Snowflake for whatever reason. I haven't dug into that yet, but I know the folks that have tried and it doesn't work. So maybe it's something to do with the connector, the JDBC connector in Glue. I'm not sure. But ultimately, the reason to use Glue with Snowflake, serverless, it's fully managed, and it's ETL. Snowflake's in the cloud, Glue's in the cloud. It just makes sense to keep everything moving in the cloud there. All right, so I'll leave with a quote here about serverless, and this is the guy who tweeted it isn't the one who said it. But serverless computation is going to fundamentally not only change the economics of what is back-end computing, but it's going to be the core of the future of distributed computing. So I think it's a pretty powerful statement that serverless isn't going away. It's going to be the core behind what we do for any of this distributed computation, and that's what's going on behind the scenes. So it's a Spark cluster behind Glue, and the person who said this is none other than the CEO of Microsoft, Satya Nadella. So a pretty prominent tech community personality there saying, hey, serverless is here to stay, and it's going to change how we do things in the future. All right, that's Going Serverless, an introduction to Glue. Any questions? All right, there's more resources, and reach out to me if you do have questions about Glue or Snowflake. There's a couple of good presentations. I think those are both from a previous reInvent, the blog about all the stuff I went through with Glue and Snowflake, and then the user group forums for Glue are pretty good. I think there's a lot of the Glue developers out there helping out. So thank you.